Hi, my name is Lukman, and today I'll be presenting my data science project, which is Telco Customer Churn Prediction. So a little bit of background for this project. Telco companies, for example, in Malaysia, we have Celcom, DG, Maxis, for example. They face this challenge, which is to attract new customers, as well as avoiding contract terminations. Here we refer to as churn. So the objective for this project, we want to analyze the features of customers who churn, and also to predict if a customer will churn or not. So how we tackling the problem? We'll be conducting churn analytics that help telco companies to deduce the underlying reasons behind churning, and also we apply machine learning models to predict churn, and from there we can take countermeasures to prevent this behavior. So this data science project will be based on the AWESOME framework, which comprises of stages from obtain, scrub, explore, model, and also interpret. And for our presentation purposes, we'll be skipping to the exploration part. Okay, so starting with the EDA, we can see the churn distribution here. About 26.5% shows that customers churn, while 73.5% shows that customers do not churn, and these are based on 7,043 records. And for machine learning modeling purposes, these are considered imbalanced data that needs to be treated to improve our accuracy. Okay, so these are the demographics features in our datasets, such as gender, senior citizens, and partner, and also dependents. You can see about an equal churn rate here for gender, while for senior citizens, they are more likely to churn, and for partner, customers without partner and also without dependents, they are more likely to churn as well. And then we can see the other categorical features in our datasets, such as phone service, multiple lines, device protection, online security. These are basically the additional features that customers can subscribe if they subscribe to that particular telco. So we can see a similar trend here. So if they do not subscribe to this additional features, when they have less additional features, they are more likely to churn compared to those who subscribe. And these are the same one as well. Streaming TV, streaming movies, if they do not subscribe to these features, they are more likely to churn. And then customers who opt for paperless billing, those who have fiber optic internet service are more likely to churn as well. And for contract, this is a rather interesting feature. Okay, so those who have shorter contract or month-to-month contract compared to longer contracts such as 1 year or 2 year, they are way more likely to churn. So this brings us to the next slide, which is the relationship between tenure and likeliness to churn. So tenure is one of the numerical data in our datasets. So tenure is basically how long the customers stay in the company. So these values are in months. So the longer the customer stays in the company, the less likely the customer will churn. Okay, and then we can see the these are the distribution for other numerical features, including tenure as well. We can see that the customer who churn, they have higher monthly charges, and then for customers who churn, they have less total charges. So this relates to the tenure as well. So they have they stay longer in the company, so they have less total charges as well. And then here, this is the heat map for the correlations with churn. We can see that there are strong positives and also strong negatives as well, like tenure, contract 2 year internet service, no total charges. While for positive, we have contract month-to-month, fiber optic, electronic charges, monthly charges. So these are some of the top features, the strong features that we can use in our predictive modeling. So the findings from our EDA. So what causes high churn rate? Basically short tenure or contract, senior citizens, customers with no partner or no dependents, customers who does not subscribe to additional services such as device protection, online backup, tech support, etc. So next step, using our initial findings, we can build our machine learning model. So the steps taken here is using correlations, we do feature selection, and then from our data sets we split into train and test data, and then treating the imbalanced training data using smooth, which is an oversampling method, and then finally we model our decision tree. So from my decision tree, I get an F1 score of 0.84 for not churn, and also 0.62 for churn, and then also an accuracy of 0.77. This results in the confusion matrix. This confusion matrix, which is basically the comparison between predicted values and also actual values. So my decision tree is able to predict a total of 1.2k of true negatives, and also 384 of true positives. So as a conclusion, we are able to find out the strong features which contributes to churn, and then build a machine learning algorithm which help us to pinpoint customers who are showing churn behavior. So when they are showing churn behavior, we can focus on these customers by introducing benefits, discounts, offers, etc. So that's all for me. Thank you so much.